Hey everybody, this is our third handout for IM3 for the first semester final. And if you can, turn up your volume because I don't think you can see my cursor moving around. I can see it, but I haven't seen it since I've changed classrooms. I don't know what makes that do that. So anyway, so here we go. It says factor each of these. So here I can pull a 2 out of all those. Let's do that first, okay? And then now we look at the factors of this right number, negative 20, that adds to 10. Well, 20 is 1 times 20, 2 times 10, 4 times 5. So the 2 and the 10 will work. The 10 is positive, so there's our answer right there. Excuse me, I'm just getting over a cold. You'll hear me clear my throat and stuff also. Sorry about that. All right, I can pull a 3 out of both of those, okay, and then recognize that that's a difference of squares, and a difference of squares always does the conjugates. So the first one squared plus the second one squared, first one, square roots of them both anyways, plus and minus, okay? All right, this is a perfect square trinomial. Factors of 25 that add to 10 are 5 and 5. So x plus 5, x plus 5, okay? And notice this is also a perfect square. This is a perfect square. They end up both becoming perfect square trinomials, and they always factor to a binomial squared. Excuse me, this sign goes in the middle, so a plus with the 10x, and then this sign next to the 20 goes in the middle here, and then the things that are being square rooted go in the middle, okay, the things that are being squared, okay, and we just have to mentally check, you guys, okay, these are perfect square trinomials. They give us a binomial squared, and then inside the binomial, just mentally multiply those. So x times 5 is 5x. It has to be double, So that's a 10x right there. We're good. 2x times 5 is 10x, has to double. That's got to be 20x, so we're good. Those ones are factored, okay? All right, let's try this, okay? Again, we got perfect square trinomials on those guys, okay? And then so this sign, this plus goes in the middle. On this one, a minus goes in the middle, okay? And then we got to check them, you guys. So 7x times 9 is 63x. Double it. That works. 8x times 5 is 40x. Double it. No, that doesn't work. This has to be an 80x, so this one doesn't factor. It's prime, okay? All right, so on this one we can GCF a 7 out and an x out. Let's do that first. Okay, and then we factor this guy. So factors of, you can do smiley face factoring. I forgot what I did. This one's pretty easy to guess and check. I'm doing smiley face factoring. Okay, good. All right, so 2 times negative 4 is negative 8. Other factors of negative 8 that add to negative 7 are negative 8 times 1. So I'm going to replace this negative 7x with negative 8x plus 1x, and then factor it by grouping. So we can group those first two together and GCF out a 2x, and out of the second 2 a 1, and we're left with x minus 4. So there's our answer. I slid it up over there because sometimes you can't see it down at the bottom down there. So there's our answer right there. All right, this one's kind of goofy, you guys. So let's go ahead and FOIL out x squared minus y squared times x squared minus y squared. Okay, so that gets us that mess right there. And then we combine all the x squared y squareds. Those are like terms. So here's negative 1x squared y squared. Here's another negative 1x squared y squared to get us a negative 2x squared y squared. And then we got a plus 4x squared y squared. So that gives us a plus 2x squared y squared all together right there. All right, and then that's a perfect square trinomial. So this is x squared squared, this is y squared squared. They become a binomial squared. Okay, so remember this sign goes in the middle, and then the things that are being squared, x squared and y squared, go on the bookends. Don't forget it's a binomial squared right there. Okay, so x squared plus y squared, that whole quantity is squared. All right, this one, you can think of this as the difference of cubes or the difference of squares, so depending on what we're looking at. So here we are, we're the difference of squares, okay? This first batch, so it's x cubed squared minus 8 squared, or it's x squared cubed minus 4 cubed. So let's see, which one did I do first? Okay, I'm separating them up. Okay, so the difference of squares does that conjugate trick, okay? So the things are being squared, you put a plus in one and a minus in one. Now those are differences in sums of cubes. So each one of those goes binomial times a trinomial, okay? So we're going to SOAP it. So binomial, trinomial. This one is also, this one here, binomial, trinomial. Same sign, opposite sign, always positive. It spells SOAP. So SOAP it, okay? Bi times tri, and then SOAP it. All right, so the things that are being cubed, the x is being cubed and the 2 is being cubed. That's what goes in these two little bi's right here, okay? And then we square the x and we square the 2. That gives me the bookends of the trinomials, okay? So that's what goes there. And then multiply the x and the 2 together. That's what goes in the middle. Okay, so here we have a cube minus a cube. So again, that's a bi times a tri. So bi times a tri. Let's see, what did I do? Oh, it's just the answer. I just took off the SOAP. I'm sorry. I forgot to put the 2 squared is 4 and the 2 squared is 4. Okay. All right. So this one is a bi times a tri. So the things that are being cubed goes in the bi. Square the x squared. Square the 4 goes over there. And then multiply the x squared times 4 is 4x squared. Goes in the middle. Okay. Clean it up. You get that? Oh, not done. This is x squared minus 2 squared. So that becomes x plus 2, x minus 2, and then times that tri. That tri never factors again, you guys. So remember, it's multiple choice, you guys. So you're looking for the correct answer that's going to fit you, okay? All right. Okay, so here I can pull an x cubed out. So when we do that, we're left with that. Factors of negative 22 are 11 times negative 2. So there we go. Okay. All right, so here we're going to add fractions. Before we add fractions, we got to get a common denominator, okay? So the common denominator is 1 plus x times x. So we'll multiply the first one by x over x and the second one by 1 plus x, and then we'll multiply that stuff out. So now they have a common denominator, and then combine like terms, we get that, okay? And I don't think that, no, this doesn't factor, so I tried factoring that. It doesn't factor, so we're done on that guy. Okay, all right, so here they already have common denominators, so we can go ahead and combine the numerators here, okay? So we get that right there. And then, let's see, I'm going to pull out a negative 1, and I get that right there. Seems to me I just did that again. I guess not. Oh yeah, so x minus 2 and 2 minus x, they're negative 1s of each other. I'm thinking of something else. Okay, so here, oh, and I am doing the same problem. So let's see, I remember doing that. Okay, here we go. So we get that. And then I'm going to pull a negative 1 out on top. It's the same problem as above, you guys. I just remember doing that earlier this morning. So you still get the same answer. So just kind of a little different technique right there. So the reason why these are negative 1s of each other is because when we pulled a negative 1 out, the negative x plus 2 became x minus 2, and it cancels out with an x minus 2 downstairs. All right. So here's this one here. Did I miss one on here? Let me look on here. 12. I think we're good. Okay, I must have done 11 twice, or the number 11 twice, so we're good. So I just did 12 as, anyway, you know what I did. Okay, common denominator is x plus 2, x minus 1. So I'm going to multiply the first fraction by the missing piece and the second fraction by the missing piece. Remember, it's over itself, because anything over itself equals 1. So when you multiply by 1, it won't change the value. Okay, now they have a common denominator, so I FOILed out on the left and distributed on the right, 7 times x, 7 times 14, and then combine all the like terms. And then I tried factoring that. It doesn't factor, so we're good. All right? All right, so here, let's go ahead and pull, so we don't have to do common denominator on this. Let's pull a 3 out on top, and it becomes 3x minus 9. So the x minus 9's cancel. There's our answer. Okay? All right, so here, the x squared minus 9 is x plus 3, x minus 3. Factors of negative 24 are negative 8 times 3, so x minus 8, x plus 3. Here I'm going to pull a 2x out, and we're left with x minus 9. Okay, cancel all the common factors. We're in the spirit of red and green, aren't we? So the x minus 8's cancel, the x plus 3's cancel, so there's our answer we're left with. Excuse me with my cold. All right, so we've got to keep, change, flip. So I'm going to keep the first fraction, flip the second fraction, and change it to a multiplication, and then factor. Okay, and then cancel out all the common factors, and you should get that. Okay, those are pretty easy. All right, so given f of x equals x squared minus 9, find f inverse of x, and then graph both f of x and f inverse x. Okay, so y equals, that's what f of x is, equals x squared minus 9. Then you flip around the x's and y's, and it becomes x equals y squared minus 9. And then we solve for the y and the y squared minus 9. So we add 9 to both sides, and then square root. There's our f inverse. Okay, let's graph this one. I'm going to graph the f of x in red. So it's a parabola, you guys. It goes down here at minus 9. So it's just a parabola. Wish you could see my cursor, but here we're down here at 0, negative 9, you guys. If we go over 1, it goes up 1 squared, which is 1. If we go over 2, it goes up 2 squared, which is 4 on both sides. If we go over 3, it goes up 3 squared, or 9. Over 4, this graph allowed me to do that. Over 4 would be up 4 squared, 16. So there's f of x right there on both sides right there. Now g of x, you guys, remember, we can't square root negative numbers, so it's going to be back here at negative 9. I can square root 0, because negative 9 plus 9 is 0. Square root of 0 is 0. But anything past negative 9, x equals negative 9, we can't graph. So we're only going to graph the positive side. Okay, so it's over here at negative 9, and you go up 1 over 1 squared, up 2 over 2 squared, and so on. So up 3 over 3 squared, okay? So this 0, 3 right here was the inverse of 3, 0. Okay, this blue point right here, which looks like it's at 7, 4, it was the inverse of 4, 7. So here's the red guy at 4, 7. Okay, so just flip the variables around, and there's your f inverse right there. All right, one more. Okay, so here's a cubic one. So again, y equals the 2x cubed, so x equals 2y cubed. And then we solve for the new y. So divide both sides by 2, and then cube root both sides. So there's our inverse function. Okay, so now we can cube root and cube negatives and positives. We just can't square root negatives. So there is no restriction when there's a cube root. So cube root of 0 is 0. I'm sorry, let's go back up here to the original function. So, well, let me show you the graph, the points right here, okay? So here's this guy. Now remember, this makes this sort of S-y sort of shape, goes down through the middle right here. All right, look, here when x equals 1, 1 cubed is 1, 1 times 2 is 2. So when we go over 1, it goes up 2. When x equals negative 1, negative 1 cubed is negative 1 times 2 is negative 2. All right, there's no room on this graph. The other graph would have been a little bit better, but this is the graph that's on your worksheet. If we went over 2, 2 cubed is 8, and then times the 2 up here would be 16. So we'd go over 2 way up off the chart at 16. Over here, negative 2 cubed is negative 8 times 2 would be negative 16, so way down here. So it makes that kind of S-y sort of shape going up through there. All right, and then we can just reverse these ordered pairs. This is 0, 0. This is, so we're going to graph 0, 0. This is 1, comma 2, so we're going to graph 2, comma 1. This is negative 1, negative 2, so just flip them around and make it negative 2, negative 1. So we just flip around those guys, and that'll give us our inverse, and it kind of goes like that. And there's a little space in between here and here where the blue guy goes down below the red guy, and so on, okay? All right, you guys, good luck on your final. Take care.